The next chapter is called Sequence of Progression, and it may be a bit of a shoehorned in mini chapter to stick between building up to master keying reduces security and then proving how master keying reduces security. So forgive the detour. It's kind of like when you go to a concert and you want to hear the hits, and then they inevitably shoehorn in a new song from the new album that you don't even care about. Anyway, sequence of progression. Now, what is that? I had, and I may have intimated this earlier, keying locks for a client. A client came in, and by the way, these videos are stretched out over different days, different weeks, and I'm aware of what I said, but not the actual nuances, so forget me specifically repeating. But a client came in and he owned like a 20 flat apartment building, and he was going to rekey all of the units over time. So he came in and we did 4 of them. And I keyed the locks for the client, and I had his master key, and then I created change keys. So the master key was 64646, just made up numbers. Well, I said, well, that's easy. So what's easy on me to key these locks? Well, the next easy thing would be to create a apartment 1, 6464, 64666, and then 64686, 64648. And if you're following what I'm doing, I just read off 3 or 4 biddings, but I broke the absolute cardinal rule. I used biddings from the TMK in the change key biddings. Guy was super happy. Here are your locks. Thank you very much. He came, he went to lunch, came back, they were done. He comes back the next day, and it's as if he had been notified he was being audited. He was not happy because apartment 1 worked apartment 3, worked apartment this and that, and it's because I completely destroyed doing it correctly. I made a huge mistake. It had to all be redone. And what happened? The client came in, and it was at that moment where I realized, how did this occur? And I studied the biddings for each key, and I can see in a pinning chart how the contamination was occurring. And it dawned on me, what's the only way to solve this problem? You never share the TMK or the master key. I didn't know it was TMK at the time. You never share any of those cuts in any change keys. You can't. Otherwise, you're not sure what's going to work. But as long as you don't have any TMK biddings in total position progression, at that time I didn't know of any other methods of progression. As long as you don't share that TMK in any change key biddings, you're guaranteed okay from the keys working each other. The bidding from the TMK, because it passes everywhere, is like its own mini master key for those individual chambers. Those chambers that share that TMK cut, keys are going to go anywhere. And I was extremely embarrassed. And this has something to do with sequence of progression. I realized that I can't share any biddings. I then chose biddings for the change keys that didn't have anything to do with the TMK. So 64646 became 86868. I mean, there's just number 2 master pins. That's not the preferable way to do it, but it works. What didn't occur to me at that time was the sequence of progression. So 64646, the first change key is 86868. I wouldn't have gone to 86860 because I got a 4 in that cut. I would have rotated the 4th chamber, 86888 is what I would have done. It didn't occur to me that I need to generate a pattern at which I rotate. But it then did occur to me at that moment, I need a systematic way to rotate these changes so that it's logical, meaning I need to rotate change key 1, and then to get to change key 2, I need to rotate a chamber so that it's logical. What I had discovered in my own mind was sequence of progression. I didn't know it was called that. I didn't know it was a rule. I didn't know that you could mix and match the rotation sequence. But I realized you have to do it in a logical fashion, and that's what I did. Rather than just, let's rotate chamber 2, and then let's rotate chamber 3, and let's rotate chamber 5, and do it in a haphazard fashion. So sequence of progression is the way in which we methodically rotate chambers in a key bitting array. We've talked about sequence of progression when we were talking earlier about the KBA. Now it's time to just talk about the sequence of progression. Let's switch to the screen view and let's jump on and do that. Okay, now we're going to go into sequence of progression. Going to blow that up a little bit so we can see it a little bit better. Okay, sequence of progression. As you know, the method of progression in the above KBA is called total pin progression, a master pin in every chamber. As you study the following, write down the SOP, sequence of progression, from the above KBA. Just from right here. This one's fine. Well, it's probably not what we're using, but it's fine. Sequence of progression. We'd probably have to go up much. Forgive me. That is the sequence of progression. That's from the KBA just above. The SOP simply defines the order in which which keys rotate. That's all it is. Our sequence of progression from above follows. Let's highlight this sentence. Let's draw attention to what we're talking about. So every KBA needs to have a sequence of progression. You don't know what's being done unless you know the order in which it's being done. And keep in mind, if you're generating any bitting lists, a key bitting array, okay, if you're generating that stuff, the philosophical question becomes is who owns that? Do you own it? Does your customer own it? It's very likely that that won't matter at some point and that someone else will have to interpret it. I have, not very often, but I have been asked for bitting lists from someone who wants to extend someone's system. Sometimes that information is shared and sometimes it's not. The times that it's not is when it's clearly someone who's not representing the owner, or it is information that I will decline to provide it to the owner's representative, but I'll supply it to them. I happen to think that I don't own it. I don't own the bitting list. It's not mine to own. I've charged for my service of creating it, but I don't own it. I charge for the hinge, and I sell you the hinge, and the transfer of ownership occurs when you get that, whether it be intellectual or tangible, I guess is how I do it. Plus, how can you own something that, it's not secret? Someone can take the lock apart and figure it out. So you might own it, but you can't prevent it from being duplicated. So this is the sequence of progression, and I'm sure I'll say again, we're going to use letters. I'm aware that some people use Roman numerals. Whatever you like. My opinion is just don't use numbers. That will help to confuse. So FEDABC, what in the gospel is that? Well, let's talk about it. Let's learn what the SOP is. You are likely familiar with an odometer in a car. The SOP on the car odometer, if you were to assign a sequence of progression of it, it would be this. A, B, C, D, E, F. It looks like this, obviously. Okay. The A column changes every 1/10 of a mile. We always said it was every block, meaning a city block, and I always watched the A column on the odometer as a kid to see if it truly clipped over at every city block in the northwest side of Chicago where I grew up. Didn't seem to be true because making turns seemed to throw it off. Anyway, the B column changes every mile, as we know. The C column changes every 100 miles, the D every 1,000, and so on. You might see factors or powers of 10 at work here. Recognizing this pattern is very helpful. Our KBA ends up working in powers of 4 in a two-step system. If we were doing Corbin System 70, it would be powers of 5 because that's single step. Our KBA ends up working in powers of 4, though System 70, Kwikset, and others are in powers of 5. Through manipulation of the KBA, you can have other derivatives too, work in other powers of, though those are advanced topics. We'll touch on that when we get to methods of progression. You can, you're not locked into, in your KBA, to squeezing out the most number of keys. Just to go off the rails for a second. In your first chamber, well, let's just say the fourth chamber, which is our A chamber. I don't have to have 7, 9, 1, and 3. If my system only needs to produce 100 keys, I could go 8 and 1 and leave it at that in a column. Have thicker master pins, basically. I don't have to have that. Okay. We're going to touch on that. It's kind of called limited position progression. Well, I'm not an expert. I'm not going to say it is or it is not called that. But the point of the matter is you don't have to do it in every individual increment step. Therefore, you would be at other work here. You can have powers of 2. Okay, you can have powers of 3 if you want. But a 2-step, 10-step system will be powers of 4 natively, inherently. Through the, let's see, back to our SOP. You will notice the first column to change, and changes every time, is the fourth chamber, because that's what A is assigned to. Your change keys are going to change by the fourth chamber first. 692741, what's the next change key? 692941. 692141, because that's the A column. If I put the A column over here like you're likely accustomed to seeing it, it'd be 692741, 692743, 692745, and so on. You can put this arrangement, this order, any way you like. Doesn't matter. You're going to get the same cuts. If you cut all 4,096 keys and put them into a barrel, and then you change the sequence of progression and cut all 4,096 keys and put them in another barrel, as you pull keys out, you're going to pull out one key from the first barrel. From the second barrel, as long as you continue to pull keys out, you're going to strike on the same key. You get the same keys, just in a different order. So you will notice the first column to change, it changes every time. It's the fourth chamber. This is the A column and therefore changes every time because it is A if it goes first. We do not use numbers for the SOP, as you can agree that it would be confusing when reading the KBA and pulling biddings from it. I mean, if you're looking at a KBA and it's just numbers down here, I don't know about you, but I'd be cutting a lot of wrong keys. So letters, Roman numerals, whatever, just not numbers. Where'd I go? Oh, too far. Yeah, too far. You will notice the A is the first to change. Use letters. Once you, let's see. Use letters or Roman numerals. Once you exhaust every combination in the A column, you change the B column to the next value. Then back to the A column and rotate through all the A's, and then change the B again. Once every possible progression is used in the B column, you then rotate the C column and start from the beginning positions of B and A. we can use our list of incidental keys from our master keying reduces security review. It is immediately below this paragraph. The A changes every cell, then the B changes every 2, the C changes every 4, the D changes every 8, the E changes every 16, and the F changes every 32. So why is A chamber 4? Anyway, this is here for you to, if you wanted to study this. That's the A column. Changes every key. The B column changes every 2. The C column changes every 4. The D column every 8. The F every 16. The E every 16. The F every 32. Just proves the point, I suppose. Why is the A chamber 4? To reuse our prior analogy, to reuse our prior analogy, imagine the least rocking place on a boat in an ocean. It's the center, and the reason I'm using this prior analogy from who knows how many chapters ago, why is A chamber 4? A is chamber 4 because it represents something closer to the center. As you take a key and you wiggle it up and down, you're going to get more extreme movement out of the F and the C here, so we want to rotate these less. And if your system's going to be smaller and you don't have to rotate and you don't have to progress the chamber like this, let's say that you just progress one position. Let's say that you have one position progression here. Let's say it's 5. Okay. Or 3. You have a really big master pin. The point is, if you have a bunch of stacked number 2 master pins in this chamber and this chamber, as you take the key and you rock it back and forth like this, with a worn key, you can get some strange things happen in terms of a key working that it shouldn't, or a master pin getting stuck, or if you have zinc-based cylinder plugs like you will in inferior lock sets. It's best practice to move those most frequent moving chambers inside of here. And all I've done is taken a standard sequence of progression and I've kind of moved it around. If I was going to do it, I would make it A, B, C, D, E, F. You see, the most often rotated positions that will have number 2 master pins, let's say, keep them near the center where your key is rocking less, is what I'm driving at there. We like the middle chamber to rotate the most, as the cylinder would be less prone to key picking. So when you've got a key in a cylinder and you're wiggling it around and you hit it just right and it will work. So therefore we move the less active sequence of progression chambers to the tip and bow areas, where you may have taller master pins. By the time we rotate the first value in the C chamber, we are already on our 17th change key. There are 4 cut possibilities in chamber A, 4 in B. 4 times 4 is 16. Therefore, the first time we rotate, we are on our 17th change key. The first time we rotate C, we're already we've got 16 change keys. Why is that important? Well, you're going to need a larger than average system before you ever call into the mix having a 1-cut key here and having a 3-cut key here that are only separated by a number 2 master pin. So we've already gone through 16 change keys where they're all going to be 1 here. The 17th key will introduce a 3, which means another number 2 master pin is going to be involved. So, or pardon me, a number 2 master pin. So when we have our first 16 changes, 741, 941, 141, it's all a number 1 bottom pin here. We're not even playing with master pins at this point because we've not progressed enough biddings to have to get to where we rotate that C column. That's the point. I hope that didn't confuse more than it was worth. All I'm driving at with the SOP is also so that you recognize a pattern, because recognizing patterns will make understanding the SPF, standard progression format, a whole lot easier. That's going to be an epic deep dive later in this primer, the standard progression format. That's the incidental keys just reproduced here so that you can see how the sequence of progression will force these keys to change. Understanding how the SOP impacts your bidding is important enough to include in this primer. It is important enough to understand this concept broadly, know its impact, but then focus on more important concepts. So the sequence of progression is not there to give you any grand level of enlightenment. You should just be aware that it's a fundamental part of the key bidding array, how you can shift things around to suit your needs, and know its role and impact in the greater overall system. But after you understand that, you're ready to move on. Speaking of moving on, the Dayton method is going to be next. Let's wrap up this video, however, on camera.